Okay, now seventh problem. This will take a long time. Anyway, we need to do this. A ball rolls on a floor towards a wall and rebounds with the same speed. This velocity is v. This velocity is also v, right? Same speed and same angle to the wall, which means what? If this is my horizontal over here, let us say this angle is theta. This angle should also be theta. What is the direction of the impulse? What is the impulse? Impulse is nothing but f delta t, which is nothing but change in momentum. We need to find out the momentum basically and take the difference. The momentum of this ball is in this direction, right? So this will be my angle theta. The momentum of the reflected ball here, okay, will be in this way. It will be like this over here. This will be your momentum of the reflected ball. So therefore, now if I take the component of this one along this direction, this will be 90 minus theta. This will be p sine theta over here, and here also this will be p sine theta over here, right? And here in a similar way, so if I take this momentum along this direction, it will be p cos theta here, and here it will be p cos theta here. Momentum of this one in that direction along the horizontal. Now what have we got? We have got two momentas in the opposite direction and two momentas in the same direction. What do we need? Change in momenta, right? Change in momenta. So let us take delta py over here first. Delta py. See, delta py would be p final minus p initial. P final is also in this direction. P initial is also in this direction. So therefore, the momentum would be 0. The value of it is not changing. Then delta px if I take. Delta px, what happens? P final minus P initial along the x direction. Which would be, what is P final over here? P final is going like this. So it is like this. Okay. It is along the negative direction. Let us write, let me take a little bit space over here to write this. So I will write delta px is equal to, oh my god, I'm not able to see the question, right? Delta px is equal to p cos theta along this direction, and then minus px. What is px over here? Initial. So p final minus p initial, right? Initial was along this direction, minus, and what is this p cos theta in this direction, right? Minus p cos theta in the opposite direction over here, right? I have indicated the arrows over here. Now let me flip one of them over here. Which one will I flip? I will flip this one over here, right? Which will be p cos theta along this direction minus, when I flip this one, this becomes plus over here, which will be p cos theta along this direction. So both of them are indicating the same direction, which will be 2p cos theta in this direction, right? So the answer should be D over here. Well, some of you might have a doubt, why should I flip this one? Why can't I flip this one? Let me do this also, even if it takes a bit longer time, doesn't matter. Okay, so therefore, if I flip this one, then what will happen? P cos theta, I can now write like this. But if I flip this arrow to the opposite direction, it becomes like this, but there is a negative sign introduced, right? This is one direction, opposite vector would be negative of this vector, minus p cos theta. I will retain the other one. I am not going to change the other one. Okay, which will now be equal to minus 2p cos theta in this direction. But if I take the positive value, then it will be in this direction itself. So therefore, again the answer comes out to be D only, right? Okay, let us move on to the question number 8.